and welcome back. In this video, we'll look at improper fractions and algebraic division. First of all, you might need to understand that every question that we've been looking at with regard to partial fractions were a proper fraction. That means that the degree of the numerator was lower than the degree in the denominator, or the coefficients of x in the numerator were lower than the coefficients of x in the denominator. Let's see an improper fraction and what's the difference with it. An improper fraction has a larger degree in the numerator than it has in the denominator. For example, you might see 3x over 3x squared, 3x squared over 3x plus 4 or 5. This isn't this is a proper fraction, but if there was an x and plus 5 in the numerator, this would be an improper fraction, and we would say that it needs to be divided first by the denominator. Okay, so let's see how to deal with improper fractions. If you had 37 over 3, first you would divide 37 by 3 and you get a 12, and the remainder would have been 1/3, or a 1, which you would put on top of the number you're dividing by. The number we're dividing by is a divisor, so you always put the remainder on top of the divisor, and you call this 12 quotient. Okay, so just like you would write 37 as 12 times 3 plus 1. If you have to write x cubed plus x squared minus 7 divided by x over 3, x minus 3 in this format, first you would perform algebraic division, because the degree of the polynomial in the numerator is higher than the highest degree in the denominator. This is 1x to the power of 1 in the denominator. This is in fact a linear factor, so we can perform a simple division. Let's see. Algebraic long division involves writing the denominator on the left side and putting the rest on the right side. So you ask yourself, what needs to be multiplied by x power of 1 to give us x cubed? Answer is x squared. So we put it there and we multiply it out. We multiply out x squared by each of these terms separately, and we write it in the denominator. Notice there was not a x, 0x in our question here, but we put a 0x there for a space filler. We need to make sure that it's there so that everything lines up properly with the rest of the word. So let's go back to multiplying x squared. We get x cubed minus 3x squared, but we're going to use a bracket, and this bracket makes sure that when we subtracting, we don't make sign errors, because yes, the x cubed and x cubed cancel away, but we are actually going to add a 3x squared to the x squared above, because minus and a minus makes a plus. Now, as I said, there wasn't any x's in the initial question, but we write 0x. That's the same as no x. So that then we will ask ourselves, what needs to be multiplied by this x here to get us 4x squared? The answer is positive 4x. So we're going to put positive 4x next to x squared and multiply positive 4x out with each of these terms. So 4x times x is 4x squared. 4x times minus 3x is minus 12x. We use a bracket so that this negative, when we subtracting, is distributed properly. 4x squared and 4x squared will cancel away, but we will have a positive 12x and a minus 7. You ask yourself again, what needs to be multiplied by this x here to give us 12x? That's simply 12. We put it there and we perform the multiplications like before. We end up with a remainder of 29. Now, 29 is has a lower power than x and minus 3, x minus 3. So that is the remainder and our division is finished. There is no more steps with algebraic division. Just like I said at the beginning, we're gonna put the remainder on top of the divisor. We were dividing by x minus 3, so we put the remain 29 over x minus 3. Okay, this matches up with what the format that the question was asking us to do. Value of A is 1, value of B is 4, value of C is 12, and D is 29. Right, so let's look at this final example here. If you perform, if you multiply out the denominator, you will get an x squared in the denominator with coefficient of 1. So we can see that already the degrees match up, but the coefficient of 3 in the numerator is larger. That means that we must perform algebraic division. Okay, so let's do that. We're going to multiply out the denominators, the x minus 1 and x minus 2, and we'll end up with this expression so that we will have an algebraic division that works. So the answer is 3, and with one soup, we will find the remainder. The remainder is 6x minus 8. Just like before, we have to put the remainder on top of the divisor. The divisor was x minus 1 multiplied by x minus 2. So let's write it like so. Now, this is the stage where we can split up x minus 3, 6x minus 8 into partial fractions. We are going to keep that 3 as it is, leave the 3 alone, and perform partial fractions. Splitting up into partial fractions will give us this. Okay, so just like before, we have to pretend that we are cross multiplying so that we get the right numerator. These two blue boxes will match. You can ignore the denominator and just deal with the numerators. Equate them to each other. Now, doesn't matter which method you choose to solve it, it should give you the same answer. B is going to be 4 and A is going to be positive 2. You put the numbers back into this part. We had 3 plus these two fractions, so we need to write 3 plus 2 over x minus 2 and 4 over x minus 2. Finally, we write the answer as so: 3 plus 2 over x minus 1 plus 4 over x minus 2. I hope you found this video helpful. I'll see you in the next section.